This video covers a standard operating procedure for the viscosity and viscoelasticity experiment. In this experiment, a Discovery Hybrid HR2 rheometer will be used to test thermoplastic and thermosetting resins. Before we begin, let's take a look at the basic functions and controls of the rheometer. The rheometer is made up of a display, top and bottom plates, environmental test chamber with oven, and control buttons near the bottom. Note, a 40mm ETC aluminum plate is used for the thermoplastic experiments, but a smaller diameter plate can be used for the thermosetting. Talk to the TA if this is not already set up, or if you wish to switch. Use the arrows to move the plate up and down, the lock button to stop the free rotation of the top plate, and zero button to set the zero of the gap between plates. You can also control the rheometer through the connected computer. Whichever method you choose, ensure to use the machine gently, making sure not to slam the plates together. Additionally, proper PPE should be worn, including safety glasses and thermal gloves, when handling the device. Before beginning the experiment, a few things must be done. First, check that the top and bottom plates are clean of any debris or material left over from a previous experiment. Next, ensure the rheometer is calibrated. Choose your geometry and perform calibrations for inertia, friction, and rotational mapping. To do this, simply click Calibrate below each option. You may have to wait a few minutes for each to complete. Lastly, you must zero the gap. In order to compensate for thermal expansion, set the temperature of the rheometer to the maximum temperature you will test. Close and lock the chamber doors, and wait. Once the temperature is reached, use a physical button or gap tab to zero the gap. The rheometer is now set up and the experiment can begin. We will first discuss the thermoplastic tests. In this experiment, both unfilled and neat 40mm polypropylene discs will be tested. A frequency sweep will be done on each for temperatures ranging 190 to 210 degrees Celsius. Ultimately, a plot of the storage modulus and loss modulus, G' and G" respectively, will be plotted against angular frequency. To begin, use an extra plate to trace out the size of the sample needed. It may be difficult to cut, so do so carefully. Set up the experiment in the Experiment tab as described in the written manual and as described on screen. Ensure the strain percent is set to 4 for the unfilled and 2 for the talc-filled polypropylene. Set the gap height to around 2000 micrometers and place the sample between plates. Close the doors and give time to heat and melt at the testing temperature. After waiting, lower the plate to the desired testing height and scrape off any excess material. Once again, close the doors and wait. Once the axial force is less than 0.1 newtons, you can run the test. Once the test is completed, use the mouse to copy and paste the data and graph onto an Excel sheet. Make sure to clean off the plates after every test. Use a spatula or a razor blade to scrape off all the material onto a paper towel. It will be a good idea to lock the plate's rotation, although it is not necessary. If the material hardens and becomes difficult to clean off, you can close the chamber doors and wait to reheat. We will now discuss a thermosetting resin. The thermosetting material is made up of benzoyl oil peroxide, vinyl ester resin, and diethylaniline. Keep track of the exact quantity you use to more easily vary the proportion of BPO. In this experiment, 3 different concentrations will be used between 4 different temperatures, 25 to 40 degrees Celsius. Calibrate and prepare the rheometer similarly to a thermoplastic experiment and copy from the written manual the inputs for experimental procedure. The goal is to plot storage modulus, loss modulus, and complex viscosity against time as the thermosetting material occurs. Begin by pouring the resin into a small disposable pan. Be careful not to spill. Weigh out the resin and measure out 1/50th, or whatever proportion you choose, of the BPO in another pan. The SOP lists 1 gram of BPO as a starting point, but much less should be sufficient, as long as enough is made to coat the plate thoroughly. Once measured out, mix the two together. Before moving any further, ensure your experiment is ready to be done. The drops of DEA act as a catalyst for the cure, and we want to ensure as much of the cure as possible can be captured. When ready to go, add 4 to 5 drops to the pan, stir together, and coat the bottom plate. Close the gap carefully, then wait for temperature to rise and axial force to drop. The experiment can then be run. Once completed, copy and paste your Excel sheet just as before. Lastly, clean up the thermosetting material. However, none of the paper towels, aluminum dishes, or gloves should be thrown in the trash. To make sure these are disposed of properly, leave them in the hazardous waste bin located under the fume hood.